Okay, so all right, so this is my email address, PILLAYPH at ukzn.ac.za. Your first port of call, I should say, are your tutors, whoever has been assigned to you, and then you can do that, or otherwise you can write to me. But you should ask them first. That will make my life a little bit easier. Okay, so let's go. The very first question we are going to do is this, this problem. You've got 25 points are placed inside a 6x4 rectangle. Prove that there exist at least 2 of the 25 points that are separated by a distance d, where d is at most root 2. Right? So we are saying that d, that there are 2 points here, at least 2 points, and the distance between them is smaller than, is at most. It means it's not greater than. So we can say less than or equal to square root of 2, which is 1,4 something. Now that's quite a demand. I mean, how do we know? These things are just thrown onto this rectangular sheet, 25 points. And how can you guarantee that there are 2 points which are close enough, like this, right? Because sometimes there may be a lot of empty space. Okay, so the way to do this is first observe that you've got a 6x4 rectangle, right? The area of that is 24, and you've got 25 points. Now that has got something to do with the problem, okay? That you've got more points than the area. Okay, let me just bring in the 24 into this scenario, and to bring it in, I'm going to divide this thing into its unit squares. You've got 6x4, so this is 4, and this is 6. So let's just divide this thing up into 6 there. Okay, that's 6. And then this way. I should be using my straight edge, but that takes a lot of time. Okay, now I've got 24 squares. So these dots are scattered on this. So I've got 25 dots in 24 squares. Can we make any conclusion from that? Or 25 points, 24 squares. Is there any conclusion that you can make from that? All right. To find out what conclusion you can make, let's ask a question. Is it possible that all 24 squares have at most 1 point? Now, by at most, it means that means it's either got 0 points or no points. It can't be more than that. Most number of points is 1. Is this possible? If you think about it, if you have either 0 or 1 point in each of these squares, then if you count the total number of points, there are 24 squares, and each square has got less than or equal to 1 point. Could be 0. Therefore, you will have 24 points altogether. Right? If so, there are not more than 24 points. I argued it out verbally. I'm going to say it again. If there are either 0 or 1 points in each of these squares, it means you've got not more than 1. Then altogether, you will have less than or equal to 24 points. Some of them are 0, some of them are 1. But whatever it is, it's less than or equal to 24 points altogether. But we are told that there are 25 points. So there's a mistake here somewhere. So the mistake is that this is not possible. If that is not possible, what does that mean? Let's translate that. It means that there is at least one square. This is logic. If not all of them, if it's not true that each square has got less than or equal to 1 point, it means that there is at least one square which has got 2 or more points. You have to think about that. This is a logical statement. Therefore, there is at least one square that has 2 or more points, because that's not possible. So what is true is that there is at least one square which has got 2 or more points. So we can assume that one of these squares have got at least 2. So let's just focus on those 2. And remember, we split this thing up into ones here. All of them are six ones and 4 ones. So the area of the sides of the square are 1 and 1. Now you've got 2 points in a small square whose in the small square, and the square has got side 1. So what does this mean? Let me just draw it nicely here. So what is the largest distance between those 2 points? These 2 points are somewhere here. The largest distance between the 2 points will have to be that distance. The distance from one corner to the other. That is the largest distance. And what is that length equal to? All these are 1. So that length must be equal to, using the theorem of Pythagoras, the largest distance is the length from one corner to the other, and that distance is square root of 2. You see? The largest possible distance is square root of 2. This is by Pythagoras. Square root of 1 squared plus 1 squared. So this distance here, if d is the distance between them, now you can see from this picture here that d is less than or equal to square root of 2. It could be equal if those 2 points actually were right in the boundary, the corner like this, then the distance is equal to square root of 2. But in all other cases, it is less than square root of 2. All right. So we have solved that problem. Prove that there exist at least 2 of the 25 points that are separated by a distance d, where d is at most 2, square root of 2. All right, although that was a mouthful, this argument here, I'm sure you understood it. And that is how you argue that there are there are 2 points whose distance between them is less than or equal to square root of 2. Now, this thing here is really an example of what we call a pigeonhole principle. See, they call this a pigeonhole principle. The reason being that you have a similar kind of a problem. If instead of this, if I had 25 pigeons going into 25 pigeonholes, these pigeons, homing pigeons, they use them to send mails and all that. So you've got 25 and you only got 24 holes. Then you can conclude that there are at least 2 pigeons in one of the holes. So this is the same argument, right? So it's called the pigeonhole principle. But there you don't say 25, you say if there are m pigeons and there are n holes, and if m is greater than n, with more pigeons than holes, then you can conclude that there is one hole, at least one hole, which has got 2 or more pigeons. In fact, I think you can say even more. You got at least something like m minus n or something like that. Okay, but at the least, you can say at least one of them has got 2 or more pigeons. Okay, so that's called the pigeonhole principle. You can go and Google this thing. Or if you got my book, go and read. Read my book, 1000 Mathematics Olympiad Problems. I keep making reference to this because I've written a lot about all this. And there I've got a lot of examples also. More than one example. I think this is one of the examples that I had. But there are many, many examples. And there are some very interesting ones where you will never believe that you can answer some of these questions which look so difficult to prove. But if you use the simple principle, the solution comes out very easily. So it's a very powerful principle, and it'll be nice for you to go and read it and try to work out more problems, be more exposed to more problems. Okay, the solid shown was made by gluing together 4 identical cubes, each of side length 1. So you got a number of cubes here, and say a cube. When you say a cube, it means all the sides are the same. All the sides are equal. But if the sides are not equal, you don't call it a cube anymore. You might have a thing like this. Like that, right? A log of wood. Now this is not a cube. You call this shape a cuboid. But a cube has got all the sides equal. Well, let's see what the question is. What is the total surface area of the solid in centimeters? Well, that should be quite easy. All you need to know, each one has got 1 square centimeter because the side length are equal to 1. So we need to know how many surfaces are exposed because you want the surface area, right? So you add up all those and add up those on this side, in the front, and there's some at the back there which you can't see, and there's one at the back of this and so on. So you can't see all the surfaces, but you can count how many there are, okay? Go to each one and count how many exposed surfaces there are. Let's try that one. Okay, there are 6 sides to a cube, right? 6, 2 at the top, 2 on the side, and then 2 front and bottom. One side is obscured. So this one has got 5 in it. And left for the same reason, that has got 5. For the same reason, the bottom one has got 5. So these 3 ones which are sticking out have all got 5 exposed surfaces. The corner one has got 3. There are only 3 exposed surfaces, which you can see because 3 of them are blocked out. And so that gives you 18 surfaces, and each one of them is 1 square centimeter, right? So therefore the surface area is 18 square centimeters. So that's an easy one. Sometimes you write, instead of square centimeters, you put centimeter squared, like that. Okay. So let's get on to the next problem. Okay, so you've got a pretty long story here. It says a sporting club has 100 members. Of these 100 members, 44 play soccer, 45 play cricket, 50 play rugby, 8 play soccer and cricket only, 9 play rugby and cricket only, 7, and so on. Right, so a whole lot of information is given here, and they ask how many members play rugby only. So this looks like a very complicated problem, but I've drawn a little diagram here, which will help you a great deal to solve that problem. See? So what I've drawn here outside is the sporting club. Okay, so I'll put the full club outside here. So what this means is that the square represents your club, right? And these represent here those who play. One of them will replace, see, those who play rugby. Let's put R here for rugby and S for soccer. Or we can put on soccer, rugby. And this is cricket. Now you will see all the rugby players are inside this circle, all the soccer players are inside this circle, and all the cricket players are inside the circle. But there's some space outside as well, which means like if there's somebody who is outside here, then this guy doesn't play any of them. He's not in any of the circles. So he does not play rugby, soccer, or cricket. He is a kind of person who plays checkers. All right. Now, you've got 100 members altogether. So altogether, you've got, the club has got 100 members. Right. Actually, it's a sporting club, so no, there wouldn't be any checkers players amongst them. They play some other sport, maybe bowls or something. Got a couple of octogenarians and nonagenarians in this club. Okay, so you say 44 play soccer. It means that altogether, here, there are 44 players. Let's just analyze this. You see, each circle is divided up into 3 segments. 4. Now, if you look at a point here, this point is in all 3. That one, that one, that one. So this point is in all 3. That means all the people here play rugby, soccer, and cricket. Okay, so that should help you now to understand what the other ones are. Like here, these people, they play rugby and soccer, but they don't play cricket in this part here. So here, the people play rugby and soccer only. Here, it is soccer and cricket only. Here, it is rugby and cricket only. Here is all 3. And here, outside, it's none. All right, so bearing that in mind, we can start filling in some of these things. You've got 44 players play soccer. So let me, altogether it's 44. So let's just bear that in mind. We'll put 44 equals soccer. That means if you add these 4 numbers, you're going to get 44. Right. 45 play cricket. So I've used that information. I've recorded that information at the bottom here. I've recorded that information. And 50 play rugby. So I've recorded that information. 8 play soccer and cricket only. Soccer and cricket only. Right? So they don't play rugby. So there are 8 here outside this. Right? So I've taken care of that. And then 9 play rugby and cricket only. Rugby and cricket. So 9 play rugby and cricket only. So that thing is 9. And 7 play soccer and rugby only. So you got that, and you don't have that, you don't have that, you don't have that. And the question is, how many people play rugby only? All right, to actually answer this, I'm going to say, let's fill in this. Let's call this X. In other words, let X be equal to the number of members who play all 3. All right, so that I put X in there. Now, the reason I do that is now you can work out a lot of things here, because when you add these 4 things, that you'll get 44. At the moment, I've got 55 minus X. To get 44, I have to kill the X, make it plus X. And 15 plus what gives you 44 is 29. So you have to put, this is minus. Right. So now when you add up these, you've got X here, and you have to put a minus X here. Altogether, you get 44. No X is there. And you got 7 plus 29 is 36 plus 8 is 44. Likewise, here you got 17 plus X in this circle. You got 45 altogether. So 45 minus 17 is 28 minus X. So now if you add up these 4, X minus X goes away. 9 plus 8 is 17 plus 8 is 45. So you use that information. And likewise, I can say this is 34 minus X. You can calculate that. So the question is, how many people play rugby only? So it looks now, of these 100 members, yeah, everybody plays one of them. There's nothing here, right? Because according to the question, it's evident that the some of them, everybody plays something, and these are the only 3 spots which are offered in this. All right. So now, in other words, when you add up all these, you're going to get 100. So let's add up all of them. And I'm just going to add all those in rugby, which I already know is 50. All right, so that is 50 there. Now these 2 here is 37 minus X. I've taken care of that. 29 plus 8. And the last one is 28 minus X. So now I've taken care of the whole lot. I added all the rugbies together one time, right, to get 50. Okay, so now this is the total number of people in the club, which we know to be 100. So there it is. You have your equation. So the whole idea is to get an equation and solve for X. So if you work this thing out, I got 87 plus 25 is 128 is 115. And it seems that I got something is wrong here. Just check these. Well, I'm sorry. So one of these figures seems to be wrong, and I can't see it straight away. But you can check this thing out. Uh, uh, I can't see the error. The reason why I'm saying something is wrong is that this thing doesn't work out. Because 2x is equal to 8715 equal to 15. Now that's not possible. So x is a whole number. Okay, so one of these things I put the wrong information here. I'm sorry about that. And 44, 50. I can't see what the error is. All right, but the point is that this is how you solve the problem. You can get one equation, one unknown, and solve for it. In this particular case, these figures don't seem to be adding up properly. Okay, let's not worry too much about that. You've got the idea now. How would you solve a problem like this? You draw a diagram, and draw 3 circles or whatever, and try to fill in each of those things. Understand what's in each segment of that circle, and go ahead and try to solve it. Okay, so let's get to the next problem. Must apologize for that. I'm not sure. Maybe these figures are wrong. Maybe I copied them wrongly. Okay. Now, question 5. Containers A and B contain mixtures of red and green paint. So you got a mixture of red and green. That's I don't know what kind of color you'll get. You mix red and green, get a rather horrible looking color. So each of these is a container. So this one has got red and green. Let's call this container A, because it says that A and B, and you have, what happens to A now? The ratio of red to green in container A is 3:1. So the ratio of red to green, suppose this is red and this is green, that means if I got 3 liters here, then I got 1 liter there. If I got 10 liters here, oh no, if I have 12 liters here, this will have to be 4, because it's 12:4. 12 over 4 is 3. So the ratio is 3:1. So we don't know how many there are, but that's the ratio. But it's all mixed up, red and green. But I'm kind of separating it to just understand the problem. Okay. Now in B, the ratio is 5:1, the same ratio. The ratio to red is to green is 5:1. Okay. Now, 6 liters of the paint in A, they got 6 liters of this paint is mixed with X liters of paint B. So you take X liters of this, but that's all together. Now you got X plus 6 liters altogether. So these are going to go into this container here. So your X liters of this, you put it here, 6 liters of this, and put it in here. And now the question is now, what is the ratio of red to green in the oh no, that's given. The ratio of red to green in the resulting mixture is 4:1. Now this is a mixture here. The ratio of red to green.
He's missed that one now. That's a shame. What an annoyance. So I really want to. Anyway, that's your answer. But we'll find out. We'll have to watch the. I've got to do the recording again now.
Sorry, I'm not sure who is talking. Please take your mics off. I think we've got that rule already, which was mentioned before. So please just bear in mind when we are listening to a class here, all microphones must be off. Okay. So you've got the ratio here is 4:1. The question is, what is the value of x? All right, now let's see now how much of red there is here. Now, here the ratio is red is to green is 3:1. And here we had 5:1. So 3:1 means 3/4 of this is red and 1/4 is green. So you got 3/4 of 6 liters, and here you got 1/4 of 6 liters. Right? So altogether you got 6. So each part will be 3/4. 3 plus 1 is 4. So you say this is how you normally do it. It's 3/4 of 6 and 1/4. If you don't like that, you can say, suppose I got A liters of red and B liters of green, right? So it means that, oh no, wait a minute, A liters of red, then there will be A liters of green and 3 liters, then you have 3 A liters of red, because the ratio of red to green is 3:1. So if you got A here, this will be 3 times that. But now these two together add up to 6, right? So therefore you'll have 4A is equal to 6. And then A is 3/2. Which is 6/4. So then 1/4 of 6 is 6/4, you see. And here you will have 3 times 6/4. So like that now, even here now you got the ratio here is 5:1. So you've got 5 plus 1 is 6. So it's 5x/6. And here you have x/6. Right. So in that mixture, if it's mixed thoroughly, this is the amount of red you will have in the mixture, and this is the amount of red you have in this mixture. Now those both things are put together. So when you create this thing here, we know you're going to get, let me work it out straight away. So 3/4 of 6 is 3 times 6/4. So that is 18/4. Plus, and here you have 5x/6. Why am I doing it? So here you'll have 5x/6. We're putting all the reds together. And the greens, here you'll have 6/4, 1/4 of 6, plus x/6. So now we know how much of reds there are and how much of greens there are. But we know that the ratio is 4:1. So you'll have that this over that is 4/1. So 18, I can simplify 18. I can make it 9/2 plus 5x/6. Red over green, 6/4 is 3/2. So you get that fraction is actually equal to 4. Right? And you have to solve for x. Now I know you guys are juniors, so you might be quite, put off by this rather horrible expression. You say, I don't know how to solve for x, yeah? Okay, it's actually not that difficult. You see, first we have to observe, if I got any fraction, say I got a fraction, 2/3. I can multiply the top by any number and multiply the bottom by any number. It won't change. That ratio won't change. These are called equivalent fractions. So I can put x equals 10, for instance, 20 over 30, right? Is the same as 2 over 3. But you can multiply any number by the same quantity, and it doesn't change. So this fraction here, this is a fraction. Right? I want to multiply the top and the bottom by the same thing. Why? Because I want to get rid of this fractions. I don't like fractions. So as far as this fraction is concerned, I'm going to multiply the top and the bottom by the same thing, and I'm going to kill the fractions. So what should I do? The way to kill it is multiply right throughout by 6, by the LCM of these. So I'll multiply this by 6. Now 9 over 2 times 6. 2 goes to 6 3 times, so we'll have 27. 5x over 6 times 6 is 5x, the 6 cancels. 3 over 2 times 6, 2 goes into 6 3 times, so you have 9. And this is x. Now only this part here is changed. Don't multiply this by 6 also, because we're only looking at this fraction whose value is the same as this. Right. Now this is very much easier to understand. I can multiply, I can make this 4 over 1, and then you cross multiply. 27 plus 5x times 1 doesn't change. It's 4 times 9. 4 into 9 plus x, so that is 36 plus 4x. So now we're coming nearer to our solution. So now that's the kind of thing you'll recognize. Bring all the x's to one side. 5x minus 4x is 36 minus 27. And there we have it. X is equal to 9. So 36 minus 27 is 9. So the answer to this problem, they asked you to find x. The answer is 9. It's a problem on ratios. And it's what you have done in primary school, but we are looking at in a problematic situation. Right. So what is important here is they've got 6 liters and the ratio is 3:1. Then the one of them is 3/4 and the other is 1/4. Right. And the same thing here. Then after that we proceed with this problem. Okay, so that takes me to the next problem. Okay. Now, between the hours 12 and 13, in other words, midday and 1 o'clock in the afternoon, there are 2 times when the hands of a clock are exactly at right angles. Now, I don't know about clock. You see, when I was young, we only had clocks. So I'm sure most of you are familiar with it, but just to recall, nowadays you've got digital clocks. So if you have 6 minutes past 8, for instance, it's not written as 6 minutes past 8. It's written as 8:06, like that, right? 6 minutes past 8. And this will come in a little box on your screen, and you'll know it's 6 minutes past 8. You don't have the hands of a clock, right? But in the old days, we used to have a clock. Some of you would have seen it, where you got a minute hand, a long hand, and the minute hand is a long hand, and it normally is pointing to something. And then you have an hour hand, which is a short hand. So the hour hand it only goes through 1 hour each time. So if I'm starting at 1 o'clock, for instance, if this is 12, 12 is always at the top. And then all the numbers from 1 to 12, all evenly spaced. So here you have 3, and here you have 6, and here you have 9, and you have 1, 2, 3. Right? And then if you're starting at 12 o'clock, after 1 hour, this minute hand comes back to 12. But the hour hand will be pointing to 1. Will be pointing to 1. So this hour hand only moves through 5. Okay, these are all minutes, right? You've got 60 minutes. So each one, there will be 5 breakages like that. So each one represents a minute. So you've got 5 12s, 60 minutes altogether in 1 hour. All right. So the minute hand will be pointing to one of these, somewhere in between. And the hour hand will be pointing anywhere along here, right? If you started at 12 o'clock. Okay. So this is what I've got here. You will see that what we have here is that they say that at some point, there are 2 times when the hands of a clock are exactly at right angles to each other. And let's see why that is so. As this thing moves from there to there, this thing goes around completely. So at some point, you'll have the minute hand is looking like that, right? And then as you go further down, this minute hand is going like that. And then at some other point, it'll be pointing like that. But this hour hand will still be in between 12 and 1. So there are 2 points where the minute hand and the hour hand are at right angles. There it is. There are 2 times when the hands of a clock are exactly at right angles. So we don't really know at which point these 2 hands are at right angles. And here too, at which, after how many minutes are these 2 at right angles to each other? And after how many minutes are those 2 at right angles to each other? All right. Now, this can be quite a hard problem if you don't know how to do it. I must confess that for many years I was doing it. I was using a very complicated method, but now recently I found a very much more beautiful method of solving these problems. See, there I was working on degrees. This is 90 degrees, right angles. But you don't have to work in degrees, you work in minutes. Right? Now, what do I mean by that? So we will say, like you see in this picture, this X minutes, we say after X minutes, not X minutes, after the hour hand moves through X minutes, after hour hand moves through X minutes. So I'm giving a name to the hour hand, how many it moves. Remember that X will have to be equal to, the most value you can have is 5, because we're going from 12 o'clock to 1 o'clock. So X will have to be between 0 and 5. So we can say instead of after, we'll say first right angle. In other words, this black one, when the thing moves to X here, there is the hour hand at right angles to this. Right. Now, I want to point out that you know how many minutes there are here, because this right angle is a quarter of a circle, right? And the circle has got 60 minutes in it. You got 60 minutes. And the right angle means that the angle between these two is 90 degrees, which is a quarter of 360 degrees. So this would have been, the minute hand would have gone through 15 minutes in this time, right? Through 15 minutes. But the hour hand has also moved. So the angle between these two is 15 minutes. So that is why you have, this is x, this is 15 plus x. See, this is quite important. So the hour hand is sitting here. Now the second time it hits 90 degrees is here, the red one. This time we are saying that the hour hand has moved through y minutes. Y is still between 0 and 5. But then the minute hand is making another 90 degrees there. So this, it is now 45 plus y minutes past 12. Here, this is 15 plus x minutes past 12. So you have to add 45 to this because this hour hand is moved through 45. I mean, the minute hand has moved through 45 minutes, right? Which is 3/4 of this thing. Okay, to make it a right angle, this is a right angle, then this is 270 degrees, and that will give you 45 minutes. Okay. So now that we've got that scenario, the next thing we observe, and this is quite important, is both the minute hand and the hour hand are moving. But one moves faster than the other, namely the hour hand. The thing is belting around this circle, while the minute hand is like the hare and the tortoise. So the minute hand is just slowly crawling towards one, while this guy has finished the entire circuit. So what it means is that when this x can only move through 1 unit, 1 hour, the minute hand has traveled 12. So the speed of the minute hand is 12 times speed of hour hand. So in the same time unit, one would have traveled 12 times more than the other, right? Okay, now let's see. Now you got 15 plus x. 15 plus x. When this thing has 15 plus x, that has moved only x. So therefore, that must be 12x. Because this thing here travels 12 times faster than the other one. Right, so this 15 plus x is 12 times that. In the same way, 45 plus y is equal to 12 times y. Okay, I'm just analyzing the information. I've named two unknowns. One unknown is where the hour hand is sitting, and the other unknown is where the minute hand is sitting. And I've got some equations by using the information that is given. So that's very nice. The whole idea in mathematics is to get equations and problem solving. So now let's ask the question, how many minutes apart are these two times? So what we really need to know is this hour hand, I mean the minute hand would have traveled 45 plus y. This is 15 plus x. So how many minutes apart are these two? So you can see this thing is going towards 60 then. So we need to know what is 45 plus y minus 15 plus x. Because in the first instance, this minute hand would have been here. The second instance, it is up there. So how many minutes apart are they? It'll have to be that number of minutes minus this number of minutes, and that is equal to, simplify this is 30 plus y minus x. So we need to calculate y minus x. So basically we need to calculate y minus x. Now, let's see here. I've got x's on both sides. So you got 11x, sorry, 11x is equal to 15, 12x minus x. And here too, I've got 11y is equal to 45. 12y minus y. So you can solve for x and y. That's very nice. X is slightly more than 1 minute, 1 and 4/11 minutes. That's understandable. It's just traveled 1 and 4. Altogether, it will travel 5. And then the second time, it is at slightly over more than 4. 11y equals 45. So y is 4 and 1/11. So it's still before 5, but that's where that is. Okay, but we need to work out x minus y. Now, straight away you can, or y minus x. So y is 45 over 11 from this equation here, and x is 15 over 11. So you can solve for both of them. That gives you 30 over 11. So y minus x is 30 over 11 minutes. So this was a problem. We need to work out what is 30 plus 30 over 11 minutes. And you can work this thing out as 2 and 8/11. So it's 32 and 8/11 minutes. So you can see this angle here is more than 30. But I mean, 30 minutes is half past, right? So it's gone more than 30 minutes. 30 minutes is half past 12. It's at 6. 6 times 5 is 30. 30 minutes past 12 is half past 12. So this is possible. So that's the answer to this question. The answer is 32 and 8/11. This is a little bit tricky, but I must tell you that you are very lucky that you got a rather simple answer. Previously, I used to have very complicated work on all kinds of angles and degrees and whatnot, right, which made life extremely complicated. Okay, so I was very happy to find a much better, to discover a much better solution. Okay, so let's just go on with the next question. The next question is oh, you got an assignment. All right, so you got an assignment. And I've written the question down, but you've been told where this assignment is. I think it's question 6 of session 5. So you can go to your problem book. But I think your tutors will tell you exactly what the problem is and make life very much easier for you. But if you didn't know that, you can go to the problem book, which was also distributed to you, and go to session 5 of the juniors and look at number 6, and you will see this problem. So it's another long, lengthy problem. I'm not going to discuss it. That's your homework. Okay, I'm happy to see that quite a number of you are handing in homework, which will benefit you greatly. All right. Benefit you in the sense that by trying out problems, you're thinking about it and you're getting answers. So even if the answer is wrong, it doesn't matter. But I think eventually you are told what the answer is. So you will learn something by doing that. At the same time, whatever marks you score will be added, and then you will have a nice free trip to Stellenbosch if you are in the upper levels of the class. Okay, so let's just have a look at the next problem. I just want to put the fan on. Yeah, in Durban, it's very hot. Ah, now I will say that's cool. And that is exactly what cool means. Not in the current usage of the term, which young people use. Cool, man. So you got this problem here. I said the diagram shows a cuboid. Oh, no, this is what I was talking about earlier on. A cuboid. It's not a cube. So the sides are all different. With height A, breadth B, and length C. Well, you can call these anything, but the three sides are A, B, and C, right? But the way it's drawn, the height is A. Right? Any of these can be the length or the breadth. Okay. Now, given that AB, now what is AB? A is one corner of the cuboid. I'll call it a box. One corner of the box. And this is the opposite corner of the box. So the distance between two opposite corners is 6. So let's just record that in this diagram. And the sum of the lengths of all the edges is 28. So if you add, now how many edges? What are edges? Those 4 edges at the top. So a cube has got 4 edges at the top, 4 edges at the bottom. That makes 8. And along the sides, it's got another 4. So every cube has got 12 edges. It's nice to know. Every cube has got 12 edges. And then, while we're on that subject, you call these faces, this part here, that flat top, is called a face. So it's got a top and a bottom face, left and right face, and then front and back face. So you've got 6 faces. Every cube has got, I'm just going off the track here, but it's nice to know these terms. 12 edges, and you got 6 faces, and you got the corners, we call vertices, and you got 4 vertices at the top and 4 vertices at the bottom, which makes 8 vertices altogether. All right. Now, there's a very, very beautiful result, quite difficult to prove. I'm not sure even if I know even now whether I know how to prove it or to understand the proof. Here you will notice that 6 plus 8 minus 12, that's equal to 2. Right? It turns out that the number of faces plus the number of vertices is always 2 more than the number of edges. Now, when I say always, it means that even if I had some other complicated picture, like for instance, I could have had a solid like this. As I say, a pyramid with a square base. Right. So rather distorted pyramid, but I hope you understand it. But it's got a, I'm including, making it look as if I can see all the sides. So you got a pyramid with a 4 base, with a square base. Here, the edges, you got 4 edges at the top, 1, 2, 3, 4, and 4 edges at the bottom. And then the vertices, you've got 1, 2, 3, 4, 5. 5 vertices, right? That's V. And then what's the other thing? Faces. Faces, you've got a triangle face here, another triangle face, another back triangle, side triangle. So there are 4 lateral faces together with the bottom one, which is also a face, a rectangle. So you got the faces are 4 triangles and 1 rectangle. And you notice that V plus F is 10, and that is 2 more than 8. Always interesting. It's called Euler's theorem. Euler was a great mathematician, brilliant, who lived a long time ago, over 300 years ago. So he discovered this very interesting fact. So I'm just giving that to you as an aside, right? It's nice for you to know it. And if you wish, you can Google it and see. Know more about Euler's theorem. Okay. So now you've got, this is 6, and the sum of all the edges. So now let's see, there are 2 A's. Actually, there are 4 A's, because there are 4 heights, and there are 4 B's. These B's, that, and that, and 4 C's. That makes the 12 edges. Right? And that sum is equal to 28. It's given that A plus B plus C, 4A plus 4B plus 4C is 28. So A plus B plus C is 7. All right. Now, they say find the total surface area of the block. Okay, now what is the surface area? The top surface is the same as the bottom surface. Let's look at the bottom surface. The bottom surface, the area is a rectangle, but you must double it, because there's another surface at the top which has got the same area, and then you can take the side surface, which is AC, and that too you have to double, right? Because you got this side, the right face and the left face got the same area, and then you got the top and the bottom. Well, no, that I've already taken care of. And then you've got the front and the back. The front is AB, and that too is doubled. So that gives you the 6 spaces, 2 in the front, 2 in the back, 2 in the sides. So this is what we need to calculate. What is 2BC plus 2AC plus 2AB, given this, that A plus B plus C is 7. And we also know that this thing here is 6. Right? This length here is 6. Now, can we get an equation involving the 6? Well, I can, but I have to do something. I have to join. You see, this is the side. Let me look at this side here. This diagonal goes right through the box, inside the box. And this is, you can see it in the side. But let me just join these two. And now I've got a triangle. With the 3 vertices given. So by joining it, let's say I've got a triangle. Do I know anything in this triangle? Well, at least I know this one. That's the same as A, right? And I know the hypotenuse. Oh, but wait a minute. This is a right angle triangle, believe it or not, right? Because this is a vertical side. If you think of a box now, if I join these 2 corners of the top square, you can see that this, because this is vertical, this line here is perpendicular to this top completely. So it must be perpendicular to this side. So this angle here, which you can't see easily, is actually a right angle. So that gives you a right angle triangle. And this is 6, that is A. Do I know this? It has to be, well, let me just see. This is C. So that is C. And so therefore this is, yeah, that is C. And this one is B. This one. And here too, I've got a right angle triangle. See, that is a corner of a square, and this becomes the hypotenuse of this right angle triangle. And the sides of this hypotenuse are B and C. So therefore, that side there is square root of B squared plus C squared. Okay, so you have to imagine all these things in space now, in 3 dimensions, what you call 3 dimensions. So you've got a right angle triangle. One of the sides is A, the other side is square root of B squared plus C squared. And therefore, by Pythagoras, the square of the hypotenuse, which is 6, is equal to the sum of the squares of the other 2 sides. So here you have A squared plus, and if you square this, you have B squared plus C squared. The square root, when you're squaring it, you come back to the original. Okay, so now you've got 2 equations, A squared plus B squared plus C squared is equal to 36. And you've got A plus B plus C is 7. Right. Now, how do you find this thing here? All right, now this is quite a demanding thing, right? You don't learn this in school, but what you do learn in school is A plus B all squared is, and those of you who are in grade 9 would have seen this. This is A squared plus 2AB plus B squared. The grade 8 students might not have seen this, but it's not A squared plus B squared, A squared plus twice AB plus B squared. That is in the syllabus. But I noticed that I've got square of A, B, and C. So I'd like to see what A plus B plus C all squared is. You might think it is A squared plus B squared plus C squared, but that is wrong. Just like this is not equal to A squared plus B squared, you have to add something else here. But it turns out that what you have to add is twice all possible products, like twice 2AB, A and B, 2AC, A and C. The only thing that is left is BC, 2BC. So this formula for the square of a sum of 3 quantities. Right? It's not in the syllabus, I admit, but it's nice to know that when you add 3 numbers and you square it, this is the formula. It looks very much like that, but you have to take twice of every possible product and then add them. Right. Now, you will notice that this is exactly what I've got here. Right. This is the thing that we're looking for. And this thing here, we just calculated it, is 36. And A plus B plus C, we know is 7. And there you have it. That this, whatever we were trying to calculate, is actually 49 minus 36. So the surface area, that is what we need to calculate, is 49 minus 36. Okay, so this is quite a demanding problem. I have to admit, this is the kind of problem that should have been in the senior paper, but I'm sure many of you would be able to understand this. And it's very good training, right? To visualize things like this in what I call 3 dimensions, but you have to have a good picture of what's happening here. So think carefully about this. I think you will have the recording for a short while, and you can go to the recording in case you didn't follow everything through. Okay, so we go to the next problem. Oh, now you got all funny looking plateaus here. So what's happening here? A scale is 40. Also, these are all scales, right? If an item has a mass less than or equal to 1,000 grams. So if the mass, whatever the weight is, if it's less than 1 kilogram, the scale is accurate. So as long as you put something which is less than a kilogram, half a kilogram, 500 grams or something like that, it'll give you an accurate reading. But if an item's mass is larger than 1,000 grams, the scale gives a random mass more than 1,000. Oh, that's horrible. So if you put two things, so one is 500, the other is 700, it'll tell you the mass is 1 million. Random. Okay, so you have no idea what the mass of that. Okay, so now you have Jeff has five weights, each less than 1,000 grams. He places two of them at a time on the scale as shown and gets the masses shown. So the 5 weights, he's given names to them. The 5 weights are just get my I'm trying to all right, okay. No, what went on here? I don't want all this. Okay, so everything went upside down here. All right, I'm back at this, and I'm back at my old problem. Okay, so that's fine. So let's have a look at this. So what Jeff does is he puts two masses. The masses are given names A, B, C, D, and E. I need to put two. He puts B and D on this, and he gets 1,200. Now, the only thing you can say is that this B plus D is bigger than 1,200. I mean, bigger than 1,000. That the weight is not 1,200. It's a random weight, right? Because it's more than 1,000. So all you can say is that B plus D is greater than 1,000. So B plus D is greater than 1,000. C plus E is also greater than 1,000. So those are the two numbers. That's all you know. Right? You don't know what the weights are. Okay. But as far as B plus C is concerned here, that's 900. So that's fine. B plus C is exactly equal to 900. And here A plus C is exactly equal to 700. And B plus C is exactly equal to 800. They're all less than 1,000. So which weight is the heaviest? Actually, you might get, confused with this, but a little bit of thought will tell you, look, I've got the same quantity here, BD I got here, and I got BC here. Now this is more than 1,000. This is less than 1,000, right? So you got B plus D must be greater than B plus C. And so if you remove, because this is more than 1,000, so you got, in other words, the D is bigger than C. So if you look at these two, you can remove the B, and you'll have D is greater than C. Now let's have a look at these two here. The same story goes here. If you remove the E, you see, this is more than 1,000. This is less than 1,000. So if you remove the E, from here you'll have the C is bigger than B. Right? And again, the E is okay here as well. In this case, you can see that this is bigger than that. This is more than 1,000. That's less than 1,000. So if I remove the P from a pan scale, you can remove the same weight, and it'll give you the remaining weights. So here, if I remove, I've got C is greater than A. Is greater than A. Is there anything else that I can do? Yeah, I've got this one here as well. If I look at this, from there, I've got the B can be removed. I've got D is greater than E. So we only can say what each one is bigger than. Right? And they're asking which is the heaviest. So they're not asking for the weights. So let's see. D is bigger than C. All right, so C is certainly not the heaviest. And C is bigger than B. Right. So now amongst these three, D is the heaviest. And the D is also bigger than E. Oh, they said the C is greater than A also. So you got D is greater than C, greater than B. No, I'm sorry. D is greater than C. These two together tell you that D is greater than B. The D is bigger than C, C is bigger than B. So D is bigger than B, is bigger than E, is bigger than C. Right, so it's B, C, and is it bigger than A also? Yeah, well, C is bigger than A. Right, so you have the D is bigger than A. So D is bigger than the whole lot of them. So D is the heaviest. Okay, so we've just extracted that information and we came to that conclusion. Okay, now here, there's a very interesting trick. You can try this trick with people. Right, here's a trick that you can try with your maths group. Challenge them to repeat it for you. Okay, I'm going to try this thing with you guys, okay? All right. Now, those of you who have your calculators with you, all right, take your calculators out. Right. Now, here, I'm going to ask you to do the following. Take any three-digit number you can think of and multiply it by 91. Take a three-digit number. Think of any three digits, whatever you like. It must be three digits. And multiply it by 91. The calculator will give you an answer. I'm going to stop share. Right. David.
Prof,
Yeah.
are we done?
So, okay. Now, I think Asishla has got a hand up. Asishla, you can put Asishla's mic on. Right.
No, you can unmute yourself. I think it's working. Or let me try.
Okay. Oh, they all can unmute themselves. Asishla, if you got your answer, if you got an answer, just put your hand up.
Darren, I tried to.
Tristan has got his hand up. Tristan, what answer did you get? I want you to tell me the last three digits of your answer, not the whole answer, please. What's the last three digits of having multiplied by 91? What's the last three digits you got? Come on, anybody. You got a calculator, multiply by 91, three-digit number times 91. Tell me what the last three digits that you see on your calculator. Come on, who is going to play this game?
Sir,
If nobody's going to play, yeah, okay, tell me.
I just have a question for number 4.
Sorry, please answer my question. Don't give me a question with a question. Have you multiplied that by 91?
Yes,
What is the last three digits of your answer?
045.
Okay, so your original number was 495?
Yes.
Right, good. Anybody else? You can ask me that question at the end. I'll answer it for you. Anybody else? Come on. You multiply by 91. What are the last three digits of your answer? All right, I'm going to close this class. Nobody wants to cooperate. Come on, anybody.
505.
50?
5.
505. Oh, so you thought of 555, did you?
Yes.
Right, good. Anybody else want to try it? Okay. But you see, I got the answer straight away. I know what number you thought of by your just giving me what the last three digits are. So that's very interesting. How do you do that? You can play this thing with anybody and you can tell them, look, magic. I don't know what number you thought of. And I'm asking you to multiply by 91. I'm not asking you to give me the whole number. I'm only asking you to give me part of your answer. And yet I can tell you what number you thought of. Now that's quite magical, right? So Colby, you also have given me an answer there. Let me. Did you think of 228, Colby? Colby gave me 748. Oh, he says yes, right. Okay, very good. Okay, so now, so the question is now, how do I know what you thought of? Right? That's an interesting question. And you can play this thing with anybody, but you must know how to do it. And I'm going to show you now what the trick is. They will think that you're a great calculating genius, but there's a trick. See, so let's take the first person. I don't know her name. She asked me a question, and I didn't take a name down. She gave me 45, and 045, and I told her that the number she thought of was 495, and the other person gave me 505, and I told him that the number that he was thinking of is 555, and Colby gave me 748, and I said that the number that he was thinking of is 228, right? And now, how did I get those answers? The trick is quite easy. All you have to do is to take those three numbers and multiply by 11. And you'll get 495. And multiply this by 11. But now you take the last three digits of your answer. When you multiply this by 11, that was very easy for me in both those cases. So I was able to answer it immediately. Because it's multiplying by 11 is easy. So the last three digits, that's what I got. Now this one took me a little bit of time. Colby gave me a rather unpleasant one. And this actually works out to 8228. And I told him the answer is 228. Right. So you have to multiply whatever they give you by 11, and it gives you the number that they thought of. Now, the big question is, what's the mathematics behind it? See? Now, I'm going to give you the mathematics behind it. It may be you might not be able to follow it too easily. But let's do it now. So your number, I don't know what this number is, so I'm going to call it n. Let n, capital N, be the number that you thought of. Let n be your number. My problem is to find out what is your n. I told you to multiply it by 91. 91n, right? And you got some answer. And I asked you to give me the last three digits of your answer, right? So if I got a number like, say, 5, 6, 8, 9, 8, the last three digits is actually 56,000 plus 898. Right? The last three digits is that number multiplied by 1,000. If I add something else, 4648, the last three digits is 4,000 plus 648. See? So you are giving me a number which I'm calling M. This is your number. Or let's call it Y. Y is your number. N is my number. I mean, your answer. Let's call it A. A for answer. And you tell me what your answer is. That's a three-digit number. So this is what you are giving me. A, right? You're giving me this. So it's equal to some multiple of 1,000, you see. We don't know what it is, but it's some multiple of 1,000. Say X times 1,000 plus A. That's what you have given. I'm going to use A to calculate N, right? And the way to do that is to multiply both sides by 11. You see, 91 is an interesting number. When you multiply 91 by 11, some of you will know that is 1,001, right? 91 times 11 is 1,001. That number is very close to 1,000. This is 1,001. Oh, I'm sorry. 1,001 N is equal to X times 1,000 plus A, right? Now, 1,000, let's make this 1,001, 1,000 plus 1. So recap, N is the number which you thought of, your number. A is the answer you gave me. So this is your N, right? And the answer you gave me. I've rubbed it out, but anyway, like 748, Colby thought of, and I told him 228. So this is the N, thought of, and this is your A, right? And I've just got this funny looking equation here. So what have you got? You got 1,000 N. So you got, if I expand this, is N plus 1,000 N, and take the other one there, 1,000 X is equal to, oh, I was multiplying this by 11, so I should have multiplied this by 11 also. 11, I multiplied this by 11, so I should multiply right throughout by 11. This becomes 11,000, and this gives you 11A. You multiply this by 1,000, right throughout, you get 11A. So you have a thing like this, N plus 1 times N plus 1,000 times N. Bring the X's to one side, and here you got 11A. Now, the number on the left-hand side, N, remember, was a three-digit number, right? But here, you're adding a multiple of 1,000. When you take any number and you add a multiple of 1,000 to it, right? This part here is actually equal to, if you look at the last three digits of this number, last three digits, of this number on the left-hand side, right? You're adding 1,000 to this. So the last three digits of this will be the last three digits of N. And that will be equal to the last three digits of 11 times your answer. Whatever was given. But N is a three-digit number, you see. So the last three digits is N itself. So therefore, your number N, this part, your last three digits, is just N. it's a 3-digit number, it's equal to the last 3 digits of A. And that is what I claimed right in the beginning. I took your answer, multiplied it by 11 A, I'm sorry, 11 A. Why do I forget the 11? So the 11 A is on the right hand side. So I'll multiply this by 11 and take the last digit and tell you that's your number. Right? So this is the mathematics behind it. And it's a little bit complicated, but please try to follow this thing. You'll learn quite a lot. Because most of it is common sense. It's just a matter of trying to understand what the symbols are, right? And get a good feel for what the symbols mean. N is the number you thought of. A is a number that you gave me. And these X's and so on are just multiples, some multiple. So I'll put an X there. Okay, so that brings me to the end of today's class. And thank you very much for listening. We only had a small number of people today, but hopefully you learned a few things. Now, we've come to the end of the class, but I just want to go to the chat group and see if there are any questions. One person asked me a question, and I told you to ask that to me at the end of the class. Can you please ask it now? Somebody had a question about question 4. Yeah. Question 4.
For question 4, it's not 100 people that play. 5 people don't play the 3 sports.
Oh, I see. So the original question had 5 people don't play at all.
Yeah. So it's 95 people play it.
Oh, okay. You remember I told you that maybe I wrote the question wrongly. So we did, 5 people play neither. Oh, there is that information. Thanks. What's your name, Ma?
Arak.
Arak. Okay. Arak, thanks very much. You see, I missed out a small vital piece of information here. 5 people play neither soccer, cricket, or rugby. So there were 5 people outside, not 0. Right? So
yes.
Therefore, these 3 things added up to 95, right? Okay.
Yeah.
Yeah, and there you will get an answer. You will get X is. I don't. Did you work it out at all?
Yeah, calculated the question.
Yeah. What was the answer?
20. So X equals to 10. Then 33 minus 10 is 23. So 23 play rugby.
Oh, I see. Okay, so X is equal to 10. Okay, thanks very much. So there is a value for X, and you need to find out how many people play rugby. So that's 23. It's 23 minus 10. I think you're going to have the X's here. I think rugby was, oh, I see. Altogether, the question is how many people play rugby only? You needed to know that, Ma. Right? So
yes.
you have to add that, and X is 10. Add those 3 things, then subtract it from that. Is that what you did?
Yes.
All right. Okay. So yeah, you say the answer was 23. Thank you very much for that. I really appreciate that. I didn't see the last part of this question. Moral of the story: read the question thoroughly. Okay. Is there anything else here? The chat group, I've got nine chats there. Okay, so 748, like it. Please resend your email address for us to ask you questions. Okay, I'm going to resend it on the screen. I'm putting it in caps. Emails doesn't really matter whether you got caps or smalls. But for me, caps matters because my writing is very bad. Caps is a little bit clearer. So it's Pillay, it's Pillay PH actually. Pillay PH at ukzn.ac.za. So if you've got any questions, you can ask it to me. But as I said, your first port of call are your immediate teachers. And if you want to call me, you're quite free to do that. Okay, then the other one, this is my first video, Colby. Colby says,